About 10 years ago, an acquisition was announced that, among other things, caused many people in the tech and investment communities to pay a lot more attention to what was happening in agriculture. Monsanto was buying the Climate Corporation, which was founded and led by David Friedberg.
Climate.com became the standalone software product for farmers. And that really is kind of, I think, the reason Monsanto bought the company and, really kind of set, I think, the first big precedent for digitization of agriculture.
In today's episode, David reflects on the Climate Corp journey and the Monsanto acquisition with AgFunder's Louisa Burwood-Taylor. He also shares a lot of his current thoughts on Agtech now that a decade has passed.
I do think that there's going to be some big opportunities for the next transformation in agriculture in multiplex precision gene editing and in metagenomics in the soil microbiome, even in breakthroughs in biologics or other platforms that can discover the next set or the next range of biologics.
David and Louisa cover everything from genomics and biologics to precision fermentation and what's still keeping him up at night and where Agtech might be headed in the decade to come.
I think the world will be surprised by how much we see acceleration and advancement in productivity in ag and food systems in the next 10 years.
David Friedberg sits down with AgFunder's Louisa Burwood-Taylor on today's Future of Agriculture podcast. Hello, fellow ag nerd. Thank you so much for joining me for another episode of the Future of Agriculture. My name is Tim Hamrich, and every week you and I get to hear from the founders, farmers, innovators, and investors, the people shaping the future of the ag industry. Now, before we dive in, I want to thank our quarterly presenting sponsor, which is a company that tells you what you don't want to know. Every 3 seconds, FarmWave's Harvest Vision system is counting your harvest losses off the header and from the combine and reporting them to you in the cab in real time. Make changes on the fly and watch your loss counts drop without having to stop or do manual harvest loss counts again. Models are currently available in corn and soybeans with several other crops in development for release soon. But don't take my word for it. Listen to an actual FarmWave customer.
The system came to me about a week after we had started doing soybeans. I had about 300 acres already through the machine at this point, our combine. And we got into that field and started going, and the system started showing you got loss out the back. The fan was set maybe just a little bit too fast. We went from non-irrigated beans to irrigated beans, so the yield was a little higher. I changed 1 millimeter on the sieve and slowed the fan down 50 RPMs. That immediately changed about 4 bushel back into the tank. And that small little change, it changed everything. I don't know how long I would have run in that field had I not had that and gone, I need to make a change.
Join the ranks of farmers deploying Harvest Vision in their fields to ensure no bushel gets left behind. Put AI to work on your farm. Just visit farmwave.io to chat with one of their experts or locate a dealer near you. Thank you so much to FarmWave for supporting farm innovation and the Future of Agriculture podcast. All right, now back to today's episode with David Friedberg and Louisa Burwood-Taylor. This interview was originally shared on the AgFunder news website, and as soon as I first listened to it, I reached out to Louisa right away to see if there was any possible chance that I could share it with you here on this podcast platform as well. She very graciously said yes, and even agreed to join me here to set things up. So here she is. You first heard her on this show, if you've been a really long-time listener, over 6 years ago on episode 42 in March of 2017. Back today to share this fascinating interview she recently did with David Friedberg is AgFunder's Louisa Burwood-Taylor. Louisa, thank you so much for being here.
Hi, Tim. Thanks so much for having me again.
Well, it's crazy to me, right, that 10 years has passed, not only since this Climate Corp acquisition that we still are talking about, probably talking too much about in general, but also since AgFunder was started, right around that same time, right?
Right, yeah. So actually, I joined in 2015. I'm effectively employee number 3, but our co-founders, Rob Leclerc and Michael Dean, started AgFunder in late 2013. And they'd been working in an agriculture project in Mali in Africa and had seen the struggle of finding funding for agriculture projects. They were also noticing, this technological revolution going on in other industries and not really coming to bear as much in agriculture. agriculture and wanted to do something about it. And so the reason that, you and I are in touch is because there was this very big deal that happened in October 2013, which was when Monsanto purchased the Climate Corporation for $1 billion. And I think we're going to be sharing an interview I did for that 10-year anniversary with Dave Friedberg. But that deal, really put this industry into the spotlight. And Rob and Michael were right there at the beginning. And they knew that they needed to kind of create an ecosystem and some understanding and education around the opportunity to invest in and innovate in the agriculture industry. So they created AgFunder News. And I was looking back, and our first ever article was published in November 2013, around Thanksgiving time. I think they'd actually incorporated the company a little bit before then, maybe in 2012, but that's when they really kicked off and got going. But at the same time, I was the founding editor of the first ever publication focused on agriculture investment called AgriInvestor. And that was founded in January 2014. And that's when I wrote my first article focused on investment in agriculture, because I'd been covering other types of financial markets until that point. At that time, I basically met Rob and Michael pretty much at the beginning and had interviewed them for AgriInvestor and knew about their mission with AgFunder. So when they invited me to join them about 18 months later, it was a very easy yes for me.
Well, and I imagine over the years you have interacted and interviewed, David Friedberg multiple times, I would guess. From 2013, that was a major deal in agriculture and in his life, but he's kind of like only grown in the public eye now with this All In podcast and very much in sort of like the public eye. Talk about kind of your interactions with David Friedberg over the years and your desire to do this interview to kind of mark the 10-year anniversary.
Yeah, so I think it's safe to say that Dave, he says he's one of the original AgFunder News subscribers. So thank you very much for that, Dave. I never actually spoke to him very much in the early years that I was covering the industry. He was busy at Climate and, we were still very much a small publication. But I remember when he moved over to the production board and I was trying to do a podcast, nothing as good as yours, obviously, my little one called Future Food. And I was thinking of people to interview for that. And I really wanted to kind of interview people that had these very big visions for what they thought the future food system was going to look like. And I reached back out to him, and that was one of the first times we'd spoken, and we did that interview. And now he's, been very generous with his time, and we stay in touch about what he's up to with the production board and so on. But yeah, it's been amazing. I remember suddenly one day, and I think I was a little bit naive or ignorant about the All In podcast, but I was looking at his Twitter followers, and suddenly I was like, whoa, what's happened there? What's happened? I'm sure that it was like, a few thousand, a few hundred, few thousand, and then suddenly it was hundreds of thousands, and it seemed like it was overnight to me. But I obviously had missed out on what had been going on with the All In podcast, I think. Yeah,
no, that show is a phenomenon, and I've been consuming content from Jason Calacanis for a long time. And I think, David's become kind of a favorite on the show. A lot of people I see say, okay, yeah, he's my favorite of the besties, as they call him on that show. But no, that's really cool. And I appreciate doing this interview, and I really appreciate you sharing it or allowing me to share it here on this podcast. Anything, though, we should make sure we mention just about this past decade with AgFunder and the growth that you've seen in this industry. It's kind of mind-boggling when you look backwards, isn't it?
Well, it is mind-boggling. So in 2013, there was about $20 billion of investment across agri-food tech. Our numbers are now combined with Agtech and food tech. And then in 2015, there was over $10 billion. 2021, we got to over $50 billion, which was obviously the massively inflated year across venture capital. But even last year, which was a down year, we were at about $30 billion of investment. There's like a total of about $200 billion of investment in agri-food tech over the last 10 years, which sounds like a really big number, and it definitely is. But what will be interesting that everyone will hear in this podcast with Dave is that, it's still kind of early days as well for our industry. We haven't seen a huge number of exits coming through, and, there's debate around why that is. But some people think, it still is early for a lot of the technologies to kind of prove out the business models and so on. So yeah, you'll be interested to hear Dave's views on that, because while he says that it's incredible what's happened over the last 10 years and just how different technological capabilities are, and he particularly references areas like ag biotech and gene editing. But yeah, I mean, it's been a wild ride. At AgFunder, we turned into a VC firm. We started launching funds in 2017, and we've now made about 60 investments. We have 90,000 subscribers globally. So yeah, it's exciting.
It's one of those things where if you don't stop and look backwards very often, when you do, it's kind of like, whoa, things have really changed. I mean, there's been some major advancements over this past decade. Very cool for you to come and share them on here. And as you know, as soon as I heard that interview with you and Dave, I messaged you instantly and asked if there was any chance I could share it on the podcast. So thank you very much for being gracious enough to allow me to do that. And we'll let the listeners enjoy this wonderful interview between yourself and Dave Friedberg.
Started the company in 2006 while working at Google. The idea was we could simulate the weather and use weather simulations to figure out the probability of any weather event occurring that we could then use to insure or sell insurance to business owners that lose money due to the weather. So a golf course or a car wash or a ski resort or even a farmer, they see their profit fluctuate based on whether it's raining, whether it's hot, whether it's cold, whether there's enough snow, and so on. So the idea was we would go and sell this weather insurance online. Business owners could plug in the weather events that mattered. They could buy the insurance. And I've probably been to every trade show you've ever heard of. I've been to the National Golf Course Owners Association. We sold through the National Car Wash Owners Association. We sold to ski resorts, hydroelectric plants, et cetera, et cetera. We started selling to farmers these insurance products probably as early as 2007, 2008. And we started to learn about agriculture and learn a lot about the needs of farmers. And in doing that, we recognized that maybe agriculture was the best market for this weather insurance stuff we were building and selling. And we decided to focus the company exclusively on agriculture around 2009. Remember, farmers put typically their entire life savings on the line every year. They're operating with very narrow margins, and their entire revenue stream is driven by the weather. So the idea was, why don't we just focus on making products specifically for farmers? And in order to do that, we had to make it really simple and easy for them to understand. So to do that, we had to figure out the relationship between the weather and all the variables in farming. Mm-hmm. So we started acquiring all these data sets that historically had not really been used. This was around 2009, 2010. At that time, we were known to be the largest users of Amazon's Elastic Compute Cloud because we were ingesting so much data to build these models that related all the variables of farming and the weather to predict outcome. In fact, we did federal Freedom of Information Act requests to the federal government in the US to get hard drives and hard drives of data. We got historical satellite data and radar data and topographic data and elevation map data and soil profiling, farm reports, shape files. All of that data today is like the mainstay, and everyone kind of just pulls it off the internet and they can get it in a couple of minutes. But we were shipping physical hard drives up to Amazon to load up on their servers so we could use that. And that allowed us to build these predictive models that related all these variables and make a simple interface for farmers. There was a web app with a map, and they could click on their field. And then once they click on their field, we would show them all this information and give them the price for insurance and relate all the variables based on what they were planting, when they were planting, what the relative maturity of their seed was, et cetera. And it turns out that a lot of the farmers were tracking the data we were providing every day in the insurance products: soil moisture, growth stage, forecasted yield, forecasted harvest date. So the analytics that underlie our core insurance offering became super valuable to farmers on their own. And that's when we set up Climate.com. And Climate.com became the standalone software product for farmers that allowed them to track, predict, and make better decisions on what they were doing on the farm. And that really is kind of, I think, the reason Monsanto bought the company and really kind of set, I think, the first big precedent for digitization of agriculture, because it was easy to use and accessible and made all these services available to farmers. And it required lots of different data to do it, and making it simple and intuitive and understandable.
Was it an easy-ish sell to them?
So we were first contacted by Monsanto, and I knew nothing about Monsanto. I thought they were just this evil company in St. Louis that did terrible things to the world and to people. John Hammer, who now is a partner at DCVC Bio, he was working on the Monsanto Ventures team, and he had reached out, and he was trying to do this Monsanto wants to come to Silicon Valley and engage with Silicon Valley conversation. So he emailed our support team or something and said, hey, we'd like to meet you guys and get together. And one of my guys said, hey, I said, well, why don't you go meet him? And he went and met John and met the team down there. And they were like, hey, they're serious. They may be interested in having a real partnership. I'm like, oh my gosh, these guys reach so many farmers. They could be a great distribution channel for us. So I started reading about Monsanto online, and not a lot of good stuff was being said about Monsanto online, but I really started to understand the business a little bit better. And several of them came in, and we kind of talked about what we do. And I think it really fit a need that they were acknowledging themselves in the market. Monsanto at that point had spent quite a bit of money on a service called FieldScript, where they were trying to do seed prescriptions for farmers as a service. They used a lot of different third parties, and it wasn't very sophisticated. It wasn't working very well. The business was fairly challenged. And I found that out after the fact, that there had been all this money and effort that had gone into this program. And so, they said, look, maybe we could work on this together. That sort of kicked off our conversations about maybe we could be an investor too and put some capital in. And then we said, well, if you're going to do that, we're really big into gathering data and using all this data to make our models better. Can you guys share all of your field trial data? Because no one has more field trial data than Monsanto. All the hybrids that they've produced, all the seed that they've produced, they know what the yields were, what fields those yields occurred at, what the dates were. We could match that with the weather, and we could start to build better models using their data set. And we said, we want your, I think it was Gen 5 data set at the time. And they came back and said, well, if we're going to give you that data, we need to own the whole company. And that's what really kind of kicked off the M&A conversations on, what would it take to buy the whole company. And a year prior, we had raised a nice Series C round from Founders Fund, and business was, kind of going well. We had this climate.com free offering for farmers, and we're about to launch our paid analytics service. So, things were looking really good. So it was like, well, in order to pull that off, we really have to do good for our last round's investors, and kind of had a hefty negotiation to get the deal done. So that's kind of how the whole thing kind of came together.
Yeah, and as you know, there haven't been many other billion-dollar exits in our space today. How did you get to that valuation, and can you see other companies coming down the pipeline that you think are going to have that?
Look, I think at the time, it was a transformative deal for agriculture. Like, it was all about the digitization of agriculture, and it was kind of this milestone that Monsanto wanted to make sure that they had the best platform to do that, and we very quickly put in place a strategy to make sure that we captured as much of the market as we could. We got the 640 Labs acquisition done and had FieldView Drive distributed, so all the farm equipment could get connected, because Deere and AGCO and CNH, they didn't really want to partner with us because they saw how much of the data we were collecting and how valuable that was going to be and how useful that relationship is. And everyone was nervous about having their relationship with farmers taken out by Monsanto. So we had to get the FieldView Drive going, and we really scaled this thing very quickly. And we had a great team and a lot of talent in data science and modeling, which nowadays, if we were a company, people would probably call us an AI company, because you just put those two letters in front of everything that's about using data to build predictive models now. But we had a great team to do that work. We had good product people that could build intuitive products for farmers, good front ends. And so I think that was a seminal kind of acquisition. Now everything's rationalizing to kind of what's the commercial potential, what's the commercial scale, what's the appropriate valuation multiple. I mean, you saw Corteva just bought Stoller, biologics company, and they paid, I think, probably around 15 times EBITDA, right? It's a scaled business. And in the last decade, we've seen a lot of these companies that have had some either horizontal or vertical sliver of digitization. Vertical in the sense that they're like doing it for pasture land for cows, or horizontal in the sense that they're creating a new data layer like drone imagery or satellite imagery. So it's so critical to integrate all the data in order to be appropriately predictive. If you don't have all the data, then you're missing a big element, and your uncertainty and error rate is very high. And so a lot of those horizontal companies have been very challenged, because no one wants to just pay for a data layer. Farmers want to pay for value. I want to pay for ROI. I want to spend $8 and get $60 back. If I can do that, I'll spend money on it. But otherwise, it's a real challenge to kind of get a recurring revenue stream going. And we've seen it time and time again with every slice or every variation of what you might call a digital ag company. So that's why so many of them have kind of asymptoted out at like 5 to 10 million of revenue maybe. And then it's hard, because at that point, they've had so much money gone in that there's no real acquirer on the other end that's going to pay a huge premium for a business doing 5 to 10 million of revenue. And so it's a really tough time for that digital segment. Meanwhile, there's been this extraordinary transformation in the digitization of biology and the digitization of genomics, the realization of genomic data. And I think like the attention and the headiness has really shifted. At this point in the cycle, it's not just about digitizing all this agronomic data and trying to sell farmers a service. Those businesses, I think, need to get profitable to survive, frankly. Okay, and maybe there's some stuff that happens from an M&A perspective, but I do think that there's going to be some big opportunities for the next transformation in agriculture in multiplex precision gene editing and in metagenomics in the soil microbiome, even in breakthroughs in biologics or other platforms that can discover the next set or the next range of biologics. So those are the two areas where I think there is still massive transformative M&A opportunity, because all the businesses, the big input companies, are realizing that their businesses are fundamentally at risk because of those two categories. And those two categories fundamentally exist because of the digitization of genomics and precision gene editing technology. So there's a massive transformation happening in plant breeding. What used to be a 7 to 13 year cycle, you can actually do 100 times better than that by doing precision gene editing in a year. And in biologics, there's so many products that seem to have extraordinary potential at replacing traditional inputs, biopesticides, biofertilizers, and we're now figuring out how to discover them and how to precision place them, which was a big problem in the first gen, and also how to engineer them and evolve them using evolutionary systems. So in biologics, I think there's also going to be maybe a set of other M&A events that we'll see over the next couple of years. So that's really where I'd pay attention to. And people use the term agri-tech, assuming it's about software and digitization, but I do think so much of the application of digital technology in agriculture is being realized in the microbiome, metagenomics, biologics, and in gene editing. So that's where I think kind of the next decade is going to take us.
So I was going to ask you about biologicals. People talk about being at 2.0 or 3.0. Where are we with biologicals? And am I right in thinking that it's really accelerated the level of efficacy in the last few years?
Yeah. So what's happened in biologicals is historically, input companies would try and inoculate microbes or get them to grow that they were grabbing from the environment. Fairly haphazard, grabbing, see what grows, see what it does. So the cost to do that, the timeline to do that, and the pipeline doesn't make economic sense. It takes years, costs $1 billion, and you only get to try a couple hundred microbes that you're able to pull out of the environment. Now, DNA sequencing costs have gotten so cheap, right? 20 years ago, it cost $100 million to sequence the human genome. Today, it costs 100, and you can do it in a few hours. So we can also sequence microbes in the environment. So when you do that, you can actually see what microbes are doing what in the environment. And those start to become your candidates for biological solutions. And the other thing you see is you see where those microbes are succeeding. Biologicals or biologics, whatever you call it, biologicals 1.0, they found a couple microbes that had some interesting efficacy. Then they said, let's use it the same way that we use all other ag inputs. We'll put it everywhere, we'll sell it to all farmers, and they'll use it indiscriminately everywhere, and it'll work. And it turns out that the hit rate is very low. Because I tell people the analogy is like putting a house cat in a jungle. When you put a house cat in a jungle, it's not going to survive. The jungle has a tree, and the tree grows nuts, and the monkey climbs up and eats the nuts, and the monkey poops and grows the tree, and the jaguar comes and eats the monkey, right? So there's like a whole environment, an ecosystem. And in every teaspoon of soil, there's 100 billion organisms that are feeding each other and modulating each other. So if you try and just apply some microbe into the soil, it's not always going to work. There are some times when it will work really well, and there's some times when it really won't. And so the hit rate for biologicals 1.0 in the way that they were being sold in the traditional inputs model, not very good. So now what we're figuring out is how do we take the right microbes that are going to work and they're going to win, that can do amazing things, and figure out how to put them in the right fields or the right parts of the field in the right way. And now this new 3.0 category is where we're taking those microbes and engineering them and evolving them to do things that nature didn't even evolve them to do. So get them to be better at fixing nitrogen, get them to be a stronger pesticide, overexpress a certain gene that generates a protein that does something functional in the environment that you're trying to get it to do. So, we've gone from just, hey, we found something cool, let's put it everywhere, to, hey, we found the right thing and we're putting it in the right place, to now we found the right thing, we're putting it in the right place. Oh, and we're also creating super version of it. So it's now going to be 10 times better and 100 times better. And so we're kind of at the cusp of that transition, I would say. We're still trying to get 2.0 right. It's not super commercial yet. But the next thing is 3.0 in biologicals, which is, I think, going to be extraordinary.
So when you came on my podcast a few years ago, I don't know if you remember, and you painted a really great picture of what the future food system would look like in 2050. And one of the things was talking a bit about local food systems. I mean, you were imagining lots of local fermentation units that people could, get their meat products from and so on. Obviously, with COVID, the idea of local food systems is something that people are talking a lot about more. And, there are entrepreneurs out there talking about actually, maybe we should be creating products for local communities and not thinking about big scale. It's sort of anti-scale kind of rhetoric going on. Can you scale local food systems?
Yeah.
And what does that look like?
I think it's more a question of cost. Can you make the cost cheaper? Okay. I love and appreciate and am myself one with idealistic ideals. Okay. So we all want to have a farm in our backyard like Michael Pollan promotes, and we all want to make our own food, but it doesn't make sense when you have an apartment building with 40 floors and you got to feed everyone in that apartment building and so on, which, is the majority of the urbanization, which is 60% of the population in the US and more in China, and is happening in Africa too. All technology starts out big, slow, expensive, and central. So think about a mainframe computer. It filled a room, it cost $15 million, it took forever to do something, and we would each be able to get the exact same thing out of it. Now we each have a supercomputer in our pocket. It's small, it's fast, it's cheap, it's more powerful, and it's personalized. I get my own version of stuff coming out of it. I think you could say the same about media production, where it started with big studios, and now we're all YouTube creators and we're all Instagram creators. And you can see this across the books and publishing and so on and so forth. So much of, I think, technology ultimately kind of finds its way to the edge of the network. And I think we're seeing that in manufacturing, particularly in food manufacturing, because what happens is a lot of new technologies emerge that allow you to shrink, speed up, and distribute the technology. At the end of 2021, there was a paper published by a team in China where they demonstrated a chemoenzymatic system for synthesizing starch. Starch is amylose and amylopectin, two molecules. And the structure of how amylose and amylopectin are put together creates the difference between all the different kinds of starches we know: potato starch, rice flour, wheat flour, and so on. They're all the same two molecules, amylose and amylopectin. So this team identified 7 enzymes from plants that basically catalyze the transformation of sugars over to starch into amylose and amylopectin. And the first step is to capture carbon from the atmosphere. So it fixes carbon dioxide. And then it uses some chemical step to start the enzymatic steps that drive the starch production. Now, the efficiency of this system was 9 times more efficient than corn, is what they demonstrated. So do we need all the land and all the resources and all the carbon and all the nitrogen and all the ammonia production that goes into growing all of these calories that we just talked about, the 85% of the world's calories, which are mostly coming to us, 60-70% of them are coming to us in the form of those two molecules, amylose and amylopectin. Theoretically, if this system is demonstrated and scaled, we could make amylose and amylopectin locally, and then on the output have it be converted into all the different things we want to consume, like rice or pasta or potatoes or French fries or all these different variants of the end products of food that many people like to consume. Now, I'm not super advocating for a Soylent type machine where you got these little, weird molecule printers all over. But I do think if you think about that, the 9 times more efficient than corn model, you can start to see why some technologies like this would allow us maybe to take what so much of the food system does, which is to grow stuff in a distributed way, ship it, process it, then we process most of our food, and then we make lots of different food, and then we ship it out to the edge of the network. Super inefficient, a lot of calories lost, a lot of energy lost, a lot of water and carbon, et cetera. These other technologies that are emerging will allow us to have systems more locally that don't necessarily even require growing stuff on the land. Now, the driver for that system will actually need to be hydrogen gas. So one thing that we do need is green hydrogen. So if we can generate green hydrogen, which you can generate from seawater, if you had a renewable power source, theoretically, you could just print out starch all day long using atmospheric carbon. Now, we're in the pre-prototype phase right now, so it's theoretical. But I think it's another good proof point that it's not just proteins, which is what we talk a lot about in precision fermentation, but we're also now starting to see a couple of companies making fats using precision fermentation. And now, theoretically, we can also make starches. We can make carbohydrates, and we can make sugars. So I do think that there's this idea that if we were to go to Mars, if we were to try and colonize another planet, we would not be growing crops. We would use a system like this to synthesize the things that people want to eat from what the atmosphere is providing, from the gases that are all around us, using a renewable power source. So I think we've got to get those energy costs down. average energy prices in the US today are, call it 11 to 15 cents a kilowatt hour. Once you get in that 1 to 3 cent a kilowatt hour price range, that's when you really have these breakthrough economics on being able to drive some of these different systems and have them work from a cost perspective locally. But they are really energy hungry. So you need to get cheap renewable energy sources, and then you can use these more efficient technologies to make the stuff that we want to consume.
What keeps you up at night?
I mean, right now, I think the big challenge all entrepreneurs and investors are facing is these kind of gaps in capital that may keep certain projects that have a good technology shot from actually getting across to the other side of the chasm, right? So if you look at public biotech companies, about 45% of them are trading below cash now. What that is telling you is that most biotech companies, when they hit a successful outcome on a clinical trial, or when they're close to, they go out and they raise more money to keep funding the clinical trials and hopefully get the product across the finish line. That's a good example of what's needed in a lot of ag tech that's going on right now in precision fermentation and cellular meat and some of these emerging categories we've been talking about. Is you need capital that as these businesses hit key technical milestones, they're able to get funded to get to the next technical milestone and get across the chasm. They're not profitable businesses on day one because they're big technology builds. And so in a market environment like this, where capital is saying, I would rather invest in things that are going to pay me 5% a year this year or next year versus making 5 times my money 10 years from now if it works, or 10 times my money 10 years from now if it works, you're seeing all the money move the near term. And that's because of the way interest rates have been adjusted, associated with problems with inflation and other macroeconomic conditions. So right now, there's a real capital problem. These big projects that historically have been fundable are becoming less fundable. And as they become less fundable, the seed investors don't want to invest in them because they're afraid the A investors aren't going to be there, who are afraid the B investors won't be there. And no one wants to come and pick up the scraps of the company that's now getting priced in a down round. And that's the other problem. So much of investors have been trained in the last 15 years to be momentum investors. You invest in stuff when it's going up. You don't invest in stuff when it's going down. In the last year, the index for growth stocks has declined by 70 to 80%. So everything is down 80%. So all private companies should be down 80%. So if you raise money at an A or a B valuation of 100, are you now worth 20? And if you're worth 20 and you've raised 40 million of cash, you're now worth less than your preference stack. And that's the wall that everyone's starting to hit. Because the investors that would do late stage investing are really nervous to fund a company that's now worth less than their preference stack. And you've got to go negotiate with the existing investors and recap and restructure. It doesn't mean the companies are valueless. It doesn't mean that there isn't something good there. It just means that the value now, like with all public companies, public biotech and growth stocks, is worth less than the cash that's gone in. And so there's a real kind of reset that's happening right now. And then, the leap of faith problem, I'm betting on the idea that if you hit these milestones, someone will be there to fund the next round. Well, today, the likelihood of that happening is down by 80 or 90%. So it's really hard to make the early stage investment too. So we're seeing a rationalization away from the kind of longer range, harder tech problems, and everyone's kind of rethinking their business model, rethinking their go-to-market and being like, okay, how do I get customers now? How do I make money now? What can I do? Should I not take on as much tech risk and just do a service? And so there's a lot of pivoting happening in the market right now. How this all shakes out, I think, could scare a lot of capital away, because then you see what feels like, a scary market time and keeps people out. So I think that's the biggest fear right now for most investors and entrepreneurs.
Where is the food tech and ag tech industry 10 years from now?
I think the world will be surprised by how much we see acceleration and advancement in productivity in ag and food systems in the next 10 years. It is unbelievable how much digitization and genomics is absolutely transforming every step of the food and ag supply chain. From the inputs to seed, to making proteins, to making the individual ingredients, to changing how we actually do manufacturing. The transitions are underway. And, having seen how turning certain genes on or off in a plant can extraordinarily expand the productivity of that plant and increase farmers' yield by 50% per acre by just turning a gene off. It really is astounding what we can do today that we literally couldn't do 10 years ago. Because remember, the other big thing that happened 10 years ago that we don't talk about that was far more important and consequential to the world than the Climate Corp acquisition by Monsanto was the realization of the potential of CRISPR-Cas9 and bringing that to market. And since then, hundreds of other gene editing tools have come to market. many of which are open sourced or royalty free and available to license. The cost of sequencing has declined. The ability in high throughput microfluidics, which allows the scale up of experimentation by several orders of magnitude. And obviously digitization continues to ramp up. In the 7 years we ran Climate Corp, by the way, we did a study that our average data use per year increased by 40x every year for 7 years. So I think we've seen that continue to be the case for the last 10 years. Maybe not to that extent, but certainly many orders of magnitude increment in data. So data, genomics, precision gene editing, high throughput engineering systems, and AI, which we haven't even talked about, which is computational prediction in genomics and computational control of physical systems and hardware. These things actually start to work together. And as they start to work together, you see these advances that we didn't even think about 15 years ago or 12 years ago. And now it's like, oh my gosh, like I could think up a phenotype. I could think up something I want to have happen with a plant in the environment. And then I could actually realize that outcome in the plant using software and some tooling that I have. And the cost to do that is so low. And when you put that toolkit in the hands of thousands of entrepreneurs around the world, some number of them will come up with extraordinary applications and outcomes from that. And I think we're just starting to see that in the early days in labs. The fact that we can now do suspension cells that are high growth rate and use cheap media to grow animal cells. The fact that we can actually make animal proteins that are price competitive with traditional animal proteins. The fact that we can get plants to be drought resistant, disease resistant, and double their yield by making a few gene edits or turning genes on or off that are native to the plant, not introducing foreign DNA, so we can avoid the bad GMO label. The capabilities are extraordinary. So I could pick any one of those and I could tell you some extraordinary track for what's going to happen over the next 10 years. But the truth is I don't know, because all of these tracks are intersecting with one another. And so we're seeing these big transformations happen that folks aren't kind of recognizing. So look, I think it's still, and it always has been, early days, right? Agriculture was humankind's first technology. We figured out that we could engineer the earth to make stuff for us. We put seed in the ground and oh my gosh, a plant came out and I could eat it. That was an incredible breakthrough for humankind. And to this day, we still take all of our skills and all of our knowledge and all of our ingenuity to accelerate and advance our ability to engineer the earth around us in balance with the earth in a sustainable way now, recognizing the importance of that to drive more outcome. And it's really exciting the next 10 years. Lots of money to be made, lots of transformation underway, lots of benefit to farmers, benefit to shareholders, and opportunity for entrepreneurs and investors.
Man, well, if you are even a little bit of an ag entrepreneur and tech optimist like I am, that last line there probably got you pumped up about the opportunities that the future may hold. Thank you so very much to David Friedberg and, of course, to Louisa Burwood-Taylor for having that conversation, recording that conversation, and, of course, allowing me to share that with you here as part of the Future of Agriculture podcast. I'll leave links in the show notes where you can go watch that interview on video if you'd like on AgFunder News' website. Also leave a link for the production board, which is David's current company. And, of course, to FarmWave, our quarterly presenting sponsor. Thank you to them for continuing to support this show. Go learn more about them at farmwave.io. Last but certainly not least, thank you for your time and your attention. I don't take it lightly. I'll be back next week with another story of ag innovation.